If you touch a hot stove, your nervous system fires an electrical impulse that pulls your hand away in milliseconds. It is an electrical network built for immediate survival, but that speed has a limit. Nerve fibers do not innervate every cell in the body, and their electrical signals are short-lived. They cannot provide the continuous regulation that cellular functions require. This creates a physiological gap. How does the body coordinate 30 trillion cells to grow, digest, and adapt without direct neural connections? The solution is the endocrine system, a wireless broadcast network using the bloodstream to reach tissues wires cannot. It relies on hormones, non-nutrient chemicals produced in trace amounts. They act as intercellular messengers, traveling to distant target organs. While the nervous system manages your rapid responses to the outside world, the endocrine system is what orchestrates the long-term internal survival of your body. Your biological daily cycle begins long before you are aware of it. Deep in the brain, the pineal gland begins the transition to wakefulness by dialing back its production of melatonin, the hormone that regulates your diurnal sleep-wake rhythm. As you wake, the hypothalamus sends releasing hormones down a physical stalk to the pituitary gland. The pituitary acts on these instructions, releasing a cascade of secondary commands to your peripheral glands, booting up the metabolic systems required for the day. This top-down chemical cascade establishes the physiological baseline that allows your body to shift from sleep into an active, alert state. By midday, a meal introduces a massive influx of glucose into your bloodstream. Without regulation, this spike would overwhelm your system's chemical balance. This visualization shows the blood glucose level rising. To counter this, the beta cells in the pancreas release insulin, which pulls the glucose metric back down toward a neutral baseline. Insulin acts on hepatocytes and adipocytes, signaling the cell membranes to increase their uptake of glucose. This moves the sugar into the cells for storage. Hours later, when blood sugar levels dip, alpha cells release glucagon. This stimulates the liver to release sugar back into the blood. Maintaining health requires this constant, silent tug-of-war. This is how the body achieves homeostasis, keeping its internal chemistry within a very narrow, survivable range. When a sudden stressor appears in the afternoon, the body must instantly shift its priority from maintenance to survival. This cross-section shows the adrenal gland, located atop the kidney. Its inner tissue, the adrenal medulla, reacts to stress by dumping epinephrine directly into your blood. This chemical dump increases heart rate and triggers the breakdown of glycogen for energy. You can see the physical effect as the pupils rapidly dilate. To deliver these orders, hormones must bind to specific proteins called receptors. Some bind to receptors on the cell membrane, generating secondary messengers. Others slip inside the cell to bind with intracellular receptors, directly influencing the genes in the nucleus. Whether the body is reacting to a crisis in milliseconds or growing over decades, the entire system relies on the precise molecular recognition between a hormone and its specific receptor. This network extends beyond the major glands. Your heart releases factors to lower blood pressure when it gets too high, and your kidneys produce hormones to stimulate the creation of new red blood cells. Because this system regulates almost every physiological function, the consequences of a factory breakdown are severe. If the pancreas fails to manage glucose, the resulting high blood sugar leads to the systemic damage of diabetes mellitus, where cells are starved of energy while sugar builds to toxic levels in the blood. We see the physical toll of these failures in historical cases of iodine deficiency. Without iodine, the thyroid cannot synthesize its hormones, leading to the massive swelling of the gland known as a goiter. Even a tiny deficit in the adrenal cortex can lead to Addison's disease, where an alteration in carbohydrate metabolism causes acute weakness and fatigue. While your nervous system provides your immediate reflexes, it is the endocrine system's continuous, invisible chemical symphony that writes the overarching narrative of your life.